You're listening to Behind the Wheels with Doug Mason, Dave Walters, and Mike Yeagley. This is a show where we talk about heavy truck and medium-duty axle-ends. Doug, Dave, and Mike bring close to 100 years of experience and expertise in the transportation business. Join us once a month to learn new things about axle-ends. Sponsored by Alcoa Wheels, the global leader in aluminum wheel innovation.
Okay.
We are hot here at 2020 TMC.
Welcome to TMC 2020, the Alcoa Wheels booth. We have a lot of stuff going on here. One of the things we've got going is this podcast. This is a new activity for Alcoa Wheels. We're getting this podcast going, and we're going to be going live today and having some of this material potentially show up on air. I'm Mike Yeagley.
And I'm Doug Mason, and this is Behind the Wheels with Alcoa Wheels. Now, wait a minute, Mike. Just a long time since you've been back to TMC, isn't it?
It is. I have not been here at TMC for several years. I've been out wandering the world, and this is my first time back here in TMC.
What is your first impression? I mean, you weren't here in Atlanta. You probably were in Orlando maybe or something like that?
Yeah, it was down in Orlando, as a matter of fact. You're right. I was down in Orlando last time, much smaller. The exhibits were nothing like this. Really is a huge difference, how much has changed. A lot of the same quality of work. The real quality work happens in those meetings, the meetings that were today, actually. For somebody like me, that's what I really enjoy. I got a lot out of that, and the quality of that has always been good.
Yeah, well, that's the wonderful thing about TMC, quite honestly, that I've really enjoyed. It's such a technical focus for the fleets to make sure that everything that we and all the other suppliers are working on really have an impact for them.
That brings up a good point. One of the problems when I was in Europe, when I was in Asia, I continually had problems with understanding what was going on with the fleets. What is happening on the fleet level? You can go talk to one fleet, two fleets. You can talk to fleets, and they'll talk to you, but there is no such thing as TMC in Europe. There is no such thing as TMC in Asia, China, anywhere in Asia. And it causes all sorts of problems for the suppliers. It's really hard to get a bead on what
just some of the standardization, I imagine, would be very difficult, too.
It's difficult to get word out to the fleets on the proper way to maintain their vehicles. One of the big problems I was running into is I had the same discussion over and over and over again because nobody really understood how to maintain their vehicles. You'd go, there's a funny thing in China. There's a missionary in China. He was in China for 20 years. And somebody was asking, well, so what's China like? And he said, you can say anything about China, and it's going to be true. That really does capture it. Some of the best maintained fleets I've ever seen were in China. And some of the worst maintained fleets I have ever seen were in China. China is such a big place that you can't make a blanket statement about it. You've got to go out there and you've got to actually talk about specifics. And what would be great is something like TMC that would standardize, introduce a higher level of standardization to some place like China that everybody would have some idea. And actually, whenever I went there, I would spend a lot of time talking to the fleets and talking to the OEMs, saying, you guys really need something like TMC.
Well, it's where the OEMs and the fleets really come together.
And the suppliers, and so it's a great organization, and you don't really realize how good it is until you go without it.
Then you sat in some of the technical sessions today?
I did. Unfortunately, the technical sessions I sat in on, they were running with a lot of administrative stuff. The one that I really wanted to be in, I got waylaid, and I ended up coming in a little bit late, and I caught just the tail end of it. What I saw was a great discussion, but wanted to be a part of more of those. There was a great discussion on the S2?
S2 tire and wheel.
Yeah, but that's always a good discussion. As a wheel guy, plenty to see, plenty to talk, hear about. So, one of the things that I thought we could talk about just to start out, there are basically two different mounting systems out there. And we mentioned this in the first podcast. We talked about the hub piloted system, and we briefly referenced the stud piloted system. We sort of brought it up as just something that's there, but we didn't really talk about it.
Yeah, it is a smaller market segment, specifically in North America.
It's
a lot of medium duty,
Yeah.
Isuzu, that type of thing.
And and that's one of the things you have in the medium duty environment. The Japanese pretty much dominate the medium duty sector even here in the U.S. You've got, like you said, Isuzu. Hino's pretty big. Mitsubishi's big. Of course, the big dog is going to be Ford and GM. They're going to dominate that space.
But Ford owns it pretty much.
But they're going to be. That's sort of an Econoline. They've got the Econoline vans. But I'll tell you, I see an awful lot of hub-piloted Asian vehicles out and just driving around. And I don't know. I would say I don't know if it's the majority, but it seems like a lot. Do you have any idea what the...
Not the percentages, no, but I mean, with the Isuzu and the Hino, they are significantly, all the cab overs are pretty much dominated by the ball seat, we would call it. And so there is a big difference between the ball seat and the standard that we would utilize on a 10-on 285/75, two-piece flange nut setup.
So when you did a lot of studies, we were looking at some of the stud-piloted systems out there, and you were looking at what...
The hard thing about the stud-piloted systems, at least what I could find, is there's not a lot of standards around it. Like the SAJ 1965 really mentions ball seat and kind of looks at the proof loads, that type of thing that are needed, but really doesn't have like a torque tension setup that we do. There's a strong standards around the two-piece flange nuts that are so common. I mean, we've got almost every truck in this place here would have the two-piece flange nut setup.
Yeah, I mean, it'd be hard to find a stud-piloted system in this place.
And so, but the problem there was, as we were trying to validate different systems, there really was no standard for torque tension. Even looking at, the Japanese standards, they would go through all of the sizes, they would go through all of the setups. Dimensions were all there, but there was really no clear torque tension setup or standard between them, and there's different torque requirements for each of them as well. And so that's one area that hasn't really been strongly standardized, and I don't know if there's really going to be a driving force for that because of the fact that most of the systems here, again, are two-piece flange nuts.
I don't know how easy it would be. I mean, it seems like it would be very, very difficult to standardize by itself. Just the technical challenges of standardizing without giving out, proprietary information. Mm-hmm. When I think of a stud-piloted system, I'm thinking about the coatings on the studs. I'm thinking about the
coatings on the nuts.
The coatings on the nuts
and the way it wears off.
Right. I'm thinking about all that technology that's bound into that system, and it's going to be at least to me, it seems like that's a lot to agree on. Mm-hmm. It's not to say they couldn't. I mean, we have in North America. We've done that work. We've agreed on what Voss and oil and how that needs to act. And so forth, and how that's going to, how the torque tension curve looks, and all that. I mean, we've been able to nail that down.
We've actually been able to globalize that between Europe and North America. Very consistent specifications.
For hub piloted only, though.
For hub piloted only, yes.
Yeah, once you get into the stud piloted systems, man, it is just, and it's one of those things that it's a smaller market, like you mentioned. It's a smaller market, and so there's not the incentive to put that much work into it. I think everybody sees that stud pilot is the past and hub pilot is the future. How much work do we really want to put into standardizing? If you're a mechanic out there and you're working in medium duty, you really have to be aware that you've got to go out and look at the standard for the vehicle that you're looking at. You have to go back to the manufacturer, the OEM manufacturer. And there's two things that if I'm talking to a mechanic, two things would worry me. If they're working on a stud-piloted system, are they torquing it to the standards, to that specific OEM standard? And then are they purchasing the OEM nuts? I don't know that you can really count on having, just some nut that looks like it's dimensionally going to work. And
well, that's been proven, like you said, in the testing that we did previously. We had a number of different manufacturers. We were trying to produce an aftermarket system, And what we did is we utilized the OEM as the standard and did all of the torque tension testing with that, and then did an A to B comparison between that and the aftermarket manufacturer. And we did not find consistency between them.
Even from OEM to OEM, right? I mean, when you took
different coatings, you know,
yeah,
different
exactly.
setups.
You take a Hino nut, put it on an Isuzu. Threads are the same, the stud is the same, but the torque tension is completely different.
Yeah,
you know?
and the torquing setup, I mean, it's very different too if you're not used to it. You've got that inner cap nut and the outer cap nut set up between the wheels. And so being able to torque that down properly and knowing how to torque it in the right sequence, it's more difficult than a standard system. Although we do have a torque setup here going on. I don't know if there's any walking by who are interested in trying their luck at figuring out how to torque a wheel properly.
We'll have to snag some people and give them a shot at this. One of the things, going back to, you know, when you talk about the inner cap nut, the inner nut and the outer nut, I don't know if, you know, if people know what that is, how that works. Do you want to run through that real quick?
Yeah, I mean, it's a standard dual system, right? We're talking about the rear wheels, the drive wheels, where you've got an inner dual and an outer dual. And the unique thing is, obviously, in a standard two-piece flange nut, you have the stud and one nut, right? You put both wheels on, you torque it down the proper sequence, everything's good to go. But when you're talking about the ball seat system, you put the inner dual on, you put the outer cap, or the inner cap nut on, excuse me, and you get that torqued properly. Then you put the outer dual on, and then you have another outer cap nut that holds that wheel in place. So you've got more interfaces going on.
It seems like, and if I remember right, you did some studies where it was really difficult because the torque of that, because what happens is that there's thread on that inner cap nut.
Correct.
Right? Let's go through this again. You put the wheel on, you put the inner cap nut on, and the inner cap nut is both threaded on the inside and the outside of that cap nut.
Yep, to accept the outer.
And so then that holds down that inner dual, and then you torque on that outer cap nut, and it's being torqued to the inner cap nut.
Correct.
You know, and so that by itself seems like it'd be very, very difficult to control what the torque tension is of the whole system.
You got a couple of sets going on there,
yeah,
right?
You've got a lot of variables all happening at once. And this is part of the reason it's so important to follow the manufacturer's recommendations.
Yeah, and the other thing you got to be careful of too when you get in that situation is the stud lengths, right?
Right.
That's one of the things that's also very unique about the ball seat system is if you have a steel wheel setup, inner dual, outer dual, or if you have an aluminum inner, outer dual, you have a different cap nut setup.
Oh, that's right.
Yeah.
That's right.
You have to...
Do you want to talk a little bit about why that is?
Well, it's more for an alignment setup, more or less, and to keep them separated. So you have the aluminum inner cap nut actually has a lip on it that goes into the aluminum bore, all right, the nut bore area.
Okay.
And so that basically helps with the alignment of the aluminum wheel in that setup.
Oh,
and
okay.
Or the overall thickness, obviously, is much bigger in the aluminum wheel.
I knew that the thickness played a role here.
Yeah.
Yeah.
And so you also have that in the steer as well. The steer also has I'll call it a sleeve that extends into the bolt hole land area.
Right.
So that is the difference between them as well. And so people can get confused. Think, well, I can just go ahead and use an aluminum wheel with the standard nuts that I had delivered with the steel wheels I had.
Right.
And that's not the case.
Right. You have to actually go out and buy those aluminum stud piloted dual. I mean, everything gets way more complicated once you go to, and the thing is once you go to stud piloted, and the thing is that they're still out there. There's still a lot of stud piloted wheels out there that are being sold today. I don't know, if
I have no idea the percentages. Medium duty, like you said, is the biggest.
And that's going to be mostly steel.
Yeah.
It's mostly going to be steel guys who are going to have to deal with this, but it's still a pretty good size market. This actually gets me thinking about our mutual friend John Kinsler.
Okay.
Yeah, I was sitting down with John, and we were talking about the hub piloted system.
Okay.
Yeah, and he was telling me about when he was part of the team that developed the hub piloted system, wrote the SAE specifications on it. it was sort of interesting. They were driving up and down, and I'm going to say it was
I-80.
Was it?
It was I-80.
Was it I-80?
Yeah, yep. The corridor. The 80-90.
Was it?
Yep.
Okay. Well, I was under the impression that it was up in Michigan.
No, it was just south of the border. They were running along the 80-90 through Indiana and Ohio.
Okay. Oh, that's right. Because was he in Indiana back in those days?
No. He'd just still been in the Detroit area.
Okay. They would torque it up, and then they'd drive with it for a little
Yep.
while, and then
That's how they figured out the whole SAJ 1965 setup.
Yeah. I actually sat down with him and went through some of those papers.
Really?
And I made copies of everything that he did, and I've got a big file.
Well,
so
I don't know if he wants to know that.
that's true.
Hey, we got our first contestant on the torque it up. See if he's going to do it in the right sequence here.
It's looking promising.
He looks like he knows what he's doing. This is good.
I think he's getting a little bit of help.
Oh. No, for anybody who is listening, we have a torquing competition going on over here.
So
you can win different prizes if you can complete the process.
Yeah, this puts you in the running for a Yeti cooler, and we got all sorts.
Oh, and a set of Alcoa wheels,
and
yeah.
the grand prize is a full set of Alcoa wheels for your truck. So.
All right, he did it. He finished it up. Good job.
Good job.
Now he gets to spin the wheel of fortune, I think. We've got all kinds of activities in the booth today.
Yeah, we do.
So we were still talking about studs and nuts and all that type of thing, right? One other thing I wanted to just point out as well, for those who are out there, again, about the stud length, right? We kind of got off the topic there. But for a ball seat system, if you change from a steel to an aluminum, all of a sudden your stud length obviously is going to be such that it's not going to extend as far into the wheel surface, right?
Right.
And so the concern there is if you do not have enough stud length, that you're going to have a fulcrum that's too large for what's there, and you can actually break the studs. You can have issues with the inner cap nuts and outer cap nut as well.
Right.
Oh, that's okay. We understand this is a working show here.
Yeah, this is.
We've got Buddy Basil working away at untorquing a wheel properly. I don't know if he's doing it right, but he's working at it. So anyway, that stud length is important, so that you're not going to have issues on the road, and you're not going to obviously break any studs off.
So you're talking about still talking about stud piloted system? Or, that's actually every system out there. Stud length is a huge
the
deal.
thing is with a standard, stud length on a standard two-piece flange nut is very obvious if you've got full engagement, right?
Yeah.
You can see the studs either flush or proud or it could be
you can
below
count
the
the
surface.
threads
Yeah, you can count the threads, and in some states that's important. I know that there's some OEMs that require 1, 2, 3 threads showing, and so that's a system where it's easy to tell if you've got a proper stud length. But in a ball seat system, you can't see it. Once you put that inner cap nut on, you have no idea where that stud is relative to the outer cap nut or the outer wheel, right?
Right.
And so it's basically a hidden situation, and you can get into a similar situation with what we call sleeve nuts for a two-piece flange nut that has a sleeve on it.
Yep.
We see that a lot in the transit industry, where they'll have a larger bolt hole diameter to accommodate a sleeve that will go into that bolt hole that actually has threads on it, so that you can get more thread engagement in a situation where the stud perhaps isn't long enough to stick through the top.
Right.
And show full thread engagement in the nut body.
That was actually developed, I think, in Europe when they were transitioning from steel to aluminum.
It's still very, very common over there, not just in the transit industry, but in over the road as well.
What we call here in North America the bus wheels, because really those 32, 10 on 335 bolt circle with the 32 millimeter bolt holes. That's almost unique. It is pretty much unique here in North America, just the bus industry.
Correct. Yeah.
But in Europe, that's everything. Actually, I shouldn't even
not
just say
every,
Europe.
it's a large percentage.
Oh yeah.
Very large percentage.
That's the equivalent of the 10 on 285/75 system that we have here.
Yeah.
And that goes for not just Europe, that's Asia, that's South America.
Oh, you're talking about just the bolt system itself.
bolt
The bolt
system.
circle. Yeah, that's right. It predominates.
Yeah.
I meant the sleeve nut
Yeah.
situation over
Well,
there. It's
and
much
even-
higher than here. But
Even the sleeve nuts, they do the same thing in China, for example. The sleeve nuts are very popular with the.
and most of that, I think the reason for most of that is they're still primarily on steel in these countries, and they're transitioning over to the aluminum. The aluminum take rate is much lower in Europe and Asia than it is here in North America.
That could be.
And so you have a situation where you want to flip a steel wheel over to an aluminum wheel in Europe. More than likely, your stud's not long enough.
Yeah.
And so in that case, you can go with a 32 millimeter bolt hole. You can use a sleeve nut, but again, you have to still have enough stud length to extend into that nut body enough so you're not coming into a situation where you're going to break studs.
And I think there's a perception, and it might even be accurate, that the cap nut, 32 millimeter bolt hole with a cap nut, is a more robust system. Basically going back to the studies that were done, I'm going to say almost 10 years ago on wheel-offs.
Okay, yeah. No, that was a wheel torque solution situation.
The Alcoa came
Yeah.
out with the wheel torque solutions, but there was a much bigger study that was done by one of the big fleets that looked into this.
Was it a waste fleet, right?
I think it was, yeah. I know it was. But what they did was that they found that movement, if there's any problems with the torque, that it creates movement of the wheel.
Yeah.
And if you put a sleeve in there, it doesn't have to be a cap nut. It could be any sort of sleeve that cuts down that motion.
Right.
Reduces the probability of a wheel off.
Yeah, coming loose.
Right.
Yeah.
And so there's a perception that's, again, I should say there's data that follows up that perception, but even without that data, what I saw in China, for example, were fleets that had plenty of thread, but they insisted on having cap nuts if they were in the bus applications.
Oh, I see what you're saying. So they were using the sleeves regardless.
Yeah.
Just because they felt that it was a more robust system for them. Okay.
Exactly. So that was one of the things that, it's funny, I spent a lot.
Well, just to go on that note a little bit further, too, there's some OEMs in Europe actually have their own nut that they use for their vehicle that actually has a small sleeve in it. That doesn't really extend that far, but it centers the wheel, and that's kind of what you're talking about,
that's
right?
Volvo, right?
Yeah, I
Volvo
think it's Volvo.
Yeah.
Yes, 32 millimeter bolt holes. You got it. Yeah. So that's a positive thing, and you don't know if that'll take off in North America at all. I know that we're working on a spec expanding the SAJ 694 to include, because that has all the interface systems.
Actually, you're right. We're going to be putting a cap nut in there, so
Yep.
it's going to get a little bit more visibility.
Well, there'll be some standards around it here in North America, which will be good as well. I know that there were some companies who were bringing in, the system, but they were not bringing it in properly. And so by having this specification here in North America, it'll mirror the specification that they have in Europe. It's a DIN specification currently. And that, I think, standardizes us more globally, which I think is a benefit. That's kind of what TMC is trying to do, is standardize things here in North America, and we'd like to relay that stuff over to Europe and Asia as well. And we can also bring some of the good practices that are in Europe and elsewhere into North America as well. Make it better for the industry overall.
Absolutely. There's so much that's going on globally, and there's so much opportunity for that crosstalk, for a little bit of information to come back from Europe. I know when I was traveling in Europe, there was a lot of interest in what's happening here. And there was also a lot of interest specifically in TMC. I think TMC did try to break into Europe, but the European market is there. You don't have the big fleets.
Yeah, it's more splintered, a lot smaller.
Much more.
The same thing in China as well.
China is the same thing. Although China is developing quickly to be a very much more like the U.S. I think China is going to be more likely to hit that sort of a U.S. model. In Europe, typically, because everything is, if you think of, let's say, Germany, I don't think Germany is as big as California, for example.
Right.
And so what you end up with is, people aren't driving as long. You don't have the long haul. You don't have, although the EU has broken down a lot of those barriers.
Yeah, there is some fleets that are going, I was working with a fleet that was going from Italy into Spain.
Right. So that is happening, but then you still have the problems with language. You still have the problems with people understanding what one another. Trust is another big thing. So there are a lot of barriers to getting a truly trans-Europe, a completely European system pulled together. But China has the advantage. It's much more like the U.S. All one language, lots of long haul. Over
very long haul.
Very long haul. And so I think China is better positioned to be for something like TMC, because what you really need are strong fleets. Otherwise,
they're going to drive it, right?
Right. You need a small number of strong fleets to drive something like this, and that just doesn't exist in Europe. But it does exist. It is coming up quickly. I mean, I know of 10,000 truck fleets that were 3 years ago were 100 truck fleets.
Right.
You're just seeing this huge growth there and a huge consolidation. And so I don't know how long it's going to be, but if China continues to be stable, there's a lot of questions around that. If China continues to be politically stable and everything else, then I could see them having something like a TMC that would really be valuable for them. That's one of those things that I think that there'd be a lot of huge benefit. And then you'd bring from China into the U.S. a lot of knowledge. If there was some sort of
sharing situation.
But even there's the barrier of the 10 on 335 system. Also, the Europeans and the Americans, like, for example, aerodynamics. Just take a look at aerodynamics. You would think that the Europeans and the North Americans would have roughly similar ideas on aerodynamics, right? But the European standard for measuring aerodynamics is dramatically different from the North American standard for measuring aerodynamics. Now, I've read through the specs, but I'm not an aerodynamic expert, But the way it looks to me is that North America takes into account acceleration and deceleration. So it takes into the account
the whole cycle.
The whole cycle. Where the Europeans have chosen, last time I looked, the Europeans have chosen to look at it from a perspective of, there's a lot of variables that are going on when you're accelerating, a lot of variables that are going on when you're decelerating. We want to be in that sweet spot where we know we have rock solid confidence in the data that we're getting. And so they've taken a completely different way of doing it.
So just at highway speed, basically, is what they're looking at?
Just at highway speed. And so what you end up with is two completely different ways to measure the exact same thing. And that's just aerodynamics. You start looking at something like 10 on 335, 10 on 285.
Definitely different philosophy.
A completely different philosophy. So you're not measuring the same thing anymore. You're measuring two different things. When you're talking about a European system and all the different maintenance issues they're dealing with, a lot of it's going to transition over, but the technology is so different. I don't know how much. It'd be great to have an engine guy here who's very familiar with.
There's an impact. Yeah, I don't have any idea.
I have no idea either. That'd be an interesting discussion. But now, one of the things, I think I shared with you that paper I was looking at where there are some researchers in Europe who are partnering with researchers in North America on aerodynamics specifically.
Okay.
And they're trying to understand how can we speak the same language, because they're recognizing there's a lot of benefit. Typically, because the North Americans have taken into account.
Oh, hey, we got some more competitors here. This is great. 2 of them.
Right.
Let's go, guys. Come on. Let's see how you can do it. This is good. You get a chance to win a Yeti cooler and a set of wheels. So anyway, back to Europe. So if they were trying to torque up a 10 on 335, would it be any different?
No, that would not be any different. You're right. That would not be any different. What I'm trying to get at is that there are efforts to commonize where we can. I'm using this aerodynamic discussion as a.
Yeah, I don't think they're ever going to standardize on the bolt circle. That's just so ingrained now between the two. But it's interesting here in North America is we run both.
We do.
And I don't know if that's true in Europe.
No.
I don't think they run some 8 on 275, which would be standard here with North America. So you get more into the smaller wheels.
Right.
There would be some more commonization, but on the 22.5 by 8 1/4 or 22.5 by 9, It's the 10 on 335 in Europe and
Right.
10 on 285/75 here, right?
So yeah. The thing is the only market that I know of in the whole world, and I'm sure there are more, but the only one I know of that uses both 10 on 335 and 10 on 285/75 is Vietnam.
Oh, really?
Yeah, because what Vietnam they do is they buy the third-hand trucks from
Okay.
wherever they can get them in the world.
Okay.
So they're picking up trucks from North America. They're picking up trucks from Europe, South America, wherever.
So wait, now help me out. In China, it's 10 on 285/75?
No, 10 on 335.
Okay, that's what I thought. Okay.
So
They followed Europe.
They followed the whole world. When Japan, in 2010, Japan made the decision they were going to go to hub piloted. Up until that point, Japan was always stud piloted.
Yep.
And they just lived right to stud piloted, and they were the last man standing when it came to stud piloted in heavy duty applications.
And they flipped to 10 on 335?
In 2010. The funniest thing is that they did it all as one. The whole country flipped on January 1st, 2010. All the OEMs flipped to the 10 on 335 hub piloted system.
We'd have a hard time doing that here.
We would have a hard time doing it. You know, I think it's probably a good time to take a break.
Okay.
Sponsored by Alcoa Wheels, the global leader in aluminum wheel innovation, manufacturing, and technology. Inventing the first forged aluminum wheel in 1948, its team of experts continue to develop the most lightweight, efficient, and high-performing commercial vehicle aluminum wheel products. Bringing you revolutionary innovations like Alcoa DuraBrite wheels, Alcoa DuraBlack wheels, the new Alcoa Wheels hubboard technology, and the lightest truck wheel on the market, Alcoa Ultra One 22.5 by 8.25 wheel. Alcoa Wheels, the global leader in aluminum wheel innovation.